Hello everyone, in this video I will show you how to read a datasheet effectively. So I will give you one example in this video, and this will be two-part video. So first I will give the example, I will give one example in this video, and then I will give another example in part 2. Okay, so let's get started. So first we will start by a pressure sensor, which is a BMP280. As you can see, this is the sensor provided by Bosch Electronics. So let me open its datasheet. Let me zoom a little bit. So as you can see, if we read this description, this is BMP280 is absolute barometric pressure sensor, especially designed for mobile application. So we can use in like portable devices like GPS modules, watches, and even also we can use that in our mobile phones. Okay, so this is the general description of this sensor. So first thing we have to look for its interfacing. So how will we interface to MCU microcontroller? So if we go to next page, see we can see the pinout of this sensor. So it has 8 pins. First pin is ground, second is CSB, third is SDI, fourth is SCK, fifth is SDO, sixth is VDD, seventh is ground, and eighth is again VDD. So these are the names of the pin. So GN is ground, CSB is chip select, SDI is serial data, SCK is serial clock input, SDO is serial data output, and VDDIO is digital interface supply. GN is again ground, VDD is analog supply. So if we see from here, sensor operation, the BMP280 features I2C and SPI. It offers both interfacing I2C and SPI, and it's up to our how we will interface. We can use either I2C or SPI. Okay, so in I2C it has 3 wire, in SPI it has 4 wire. So let me talk about SPI. In SPI we have 4 pins. One is chip select, and second is MOSI, third is MISO, and fourth is clock. So if we talk here, and if we talk about this, so our sensor will be slave and our MCU will be master. So this sensor has SDI and SDO. So it means serial data input. SDO means serial data output. So it means if we want to send some data from MCU to this sensor, we will use SDI pin, because our MCU will be master and this sensor will be slave, so it will accept the input from the master. So it will accept from this pin, serial data input. So this will be this will connect to the MOSI pin of MCU. Okay, because in that case MCU will send data, so it will be master out and it will receive the data, so it will slave input. And another pin is SDO. So this pin is used to give back data to MCU. If we transmit some data to MCU, so this will be used SDO. So SDO will be connected to MISO pin of SPI in microcontroller, because master will receive the data and sensor will send the data. And in the case of clock, we will use this pin SCK, serial clock input. And in the case of chip select, we have this pin, second one, CSB. So this was the case of SPI. If we talk about I2C, I2C has 2 pins, SDA and SCL. Okay, so and I2Cs are half duplex, so it means we can send and receive data on the same pin. Unlike SPI is full duplex. We will need 2 pins for input and output. So okay, So I2C requires less wire as compared to SPI. So in the case of I2C, what pins we will use? So we will use SDI pin as SDA and SCK as a clock, and we will set SDO to high or low, whatever depend mentioned in the datasheet. Okay, and we can try by ourselves if we give high to SDO if it's working or not, and if we will give ground to SDO if it's working or not. We can try it ourselves. So okay, so this was the case of SPI and I2C. The next thing we will have to look for its electrical specification, like how much current it will require. So we will, if this is a battery operated device, so we have to take care of that. So if we operate this device if we want to operate this device for a long time, so we have to look at its current requirements. So as you can see from here, the average current consumption is 2.74 microampere. This is in the case of ultra low power mode. It means when this sensor is not sensing anything, so it requires 2.74 microampere. And in the case of supply voltage, it means 1.2 volt to 3.6 volt. In the case of VDDIO, in the case of VDD, it requires 1.7 volt to 3.6 volt. And this is its range of the pressure sensor. It can sense from 300 to 1100 HPA, and it can work in this temperature 0 to 65 degrees Celsius. Okay, so how much time it require to measure pressure? So it requires 5.5 millisecond, and yeah, so this is all. This is sufficient for this video. So I will see you in part 2. Okay, bye.